Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 8th grade topic, geometric reflections. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. At the end of this video, I'll be putting a link to my 8th grade playlist in which I cover a ton more topics. So if you're interested in that, make sure you stay tuned. If you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have a bit to cover, so leave a like, smash the subscribe, and let's get started. Now, there's a lot you can say about geometric reflections. So much so that it might be better to not squeeze it all into one video and overload you all at once. So I think I'm going to actually break up this topic into 2 videos. In today's video, we'll be covering reflecting over the x-axis and the y-axis. And I may even show you another vertical line or horizontal line just to throw it in the mix. And next week, we'll be covering reflecting over the line y equals x and y equals negative x. So this is going to be next week's, and today we're going to focus on just the x-axis and the y-axis. So last week we covered geometric translations and we talked about what those were. So if you missed that, no worries, I have a video, you can find it right up here. Check it out at any point in time. But the long and short is that geometric translations cause every point in your graph to move exactly the same way. That means if you have a graph with 3 points and it tells you to translate it up 3 and to the right 2, right? That means every point is going to do this. So this point, and that point are moving exactly the same way. This is not true for reflections. Don't get them confused. Translations cause every point to move the same exact way, but reflections, I want you to think about your reflection in a mirror. Let's say you have a mirror here and you're looking at it from the side. What do you see? Well, you see yourself, and I'm going to try to do this as best I can here, looking back at you. This is how reflections are going to work. You're pretty much on whatever line. Remember, we have a few different lines that we can be discussing, half today and half next week, but whatever line you're reflecting over, you're going to pretty much see yourself. This means that points on your graph are going to move differently depending on how far they are from this line. So whereas translations worked on every point exactly the same way, the position on your graph and how far it is from the line you're reflecting over is going to have an effect on how that point moves. In this case, this point is going to move a lot less than, let's say, this point. But let's look at a few examples to drive this point home. Let's look at our first example for today. In this example, we have a graph that we're supposed to reflect over the y-axis. You see, we're reflecting over the y-axis. Now, this is our x-axis down here, and this is our y-axis up here. What does it mean to reflect over the y-axis? And I want you to be thinking mirror image. Think of your mirror at home. What does it mean for something to reflect over the y-axis? Well, that means that the y-axis is effectively going to be our mirror. So whatever's on one side of the y-axis has to show up on the other side of the y-axis exactly the same way. Now, what do I mean by exactly the same way? Well, if you were looking in a regular mirror, would you automatically be super big or super small? No, you look just like you. So make sure when you're reflecting, this is not a crazy house mirror. There's no crazy reflections here. Your graph should pretty much look like the graph that you had here. It shouldn't be any drastic change in shape or size. So the first thing we want to do is pick a point. Let's say we start with A. We're going to reflect A first, and then go to B and then C. Now you can do this for a single point. You can do it for even a line. It doesn't have to be a graph every time, but if you could do it for a graph with multiple points, you could do it for less points. So what does it mean for A to be reflected over the y-axis? Well, if it's going to show up pretty much as a reflection, Does that mean that A can be down here? No, A can't go into this quadrant here because it has to reflect over the y-axis. The y is the mirror. X is not a mirror. Y is a mirror. So that means we shouldn't be dropping anywhere. We shouldn't be moving this, right? How about in this quadrant? Can A show up here? No. A can't show up here because although, yes, we are reflecting, and it's going to show up on this side, we're expecting it to be over here. That's where our reflection is. You don't look in the mirror and all of a sudden your reflection is a lot lower than you are. You don't do that. So this has to be pretty much eye level. Think your mirror at home, eye level. What does that mean for A? That means A is not going to be going up or down on the y-axis. It's going to stay exactly where it is and move across the x-axis. But how far do we move? If we are 1 away from the y-axis on this side, we're going to have to be 1 away from the y-axis on this side. So we're going to travel 1, 2 spaces. And this marker is pretty much dead. One moment. All right, I'm back. So we moved 2 spaces, and that looks much better. That is our point A prime. How about B? We said that we're not going to be going up or down. We're just going to be moving across the x-axis. Remember, eye level. So we are 1, 2 away from the y-axis on this side, which means we have to be 1, 2 away on the y-axis on this side. So here is our B prime. How about C? Same thing. We're 1, 2, 3 away on this side. So we're 1, 2, 3 away on this side. And this is C prime. So if I was to connect these dots, we would have our reflected graph. One moment. Now forgive me, this drawing is not perfect, but you can see what I'm going for. The shape is pretty much the same here. The only thing that's different is that mirror image. Remember, a mirror image is not an exact image. If you was to walk up to your mirror and you touch it with your right hand, it looks like your left hand is touching it. And that's the same thing that we're seeing for this graph in its reflection. That's how you know that you've properly reflected over your y-axis. But before we move on to our x-axis, let's look at a few things that happened here. Let's look at our points A, B, and C and see if we can develop a rule when we're reflecting over the y-axis. So A was 1, 2. It was a point 1, 2. B was 2, 1. And C was 3, 3. Now we want to find our A prime, B prime, and C prime. So A prime was -1, 2. B prime was -2, 1. And C prime was -3, 3. So do you see anything funny happening with our points here? When we're going from our A, B, C to our A prime, B prime, and C prime, do you see anything crazy happening? Now, although we discussed this already, you can now see it with numbers. Our y's are not changing. We made sure that was true because we have to remain eye level with our reflection. So our y's are not changing. However, our x's seem to be negating. We have the same absolute value, but the sign is different. So this tells us that we have a nice rule whenever we're reflecting over the y-axis. So whenever you're reflecting over the y-axis, your p prime, whatever the point may be, is going to be a -x over your y. So whatever xy you start with, your prime is going to be a -x, y. So p starts at xy, p prime is going to be -x, y. That's a quick shortcut for whenever you're reflecting over the y-axis. So let's move on to the x-axis. So we're going to reflect over the x-axis for this problem here. And we're going to use the same exact shape, and we're going to see how it looks compared to when we're reflecting over the y-axis. So reflecting over the x-axis is going to have pretty much the same concept, except our mirror is different now. Instead of our mirror being over here, our mirror is down here, but we're going to attack it the same exact way. So you start with a point, let's say A. And instead of moving A over here, remember we have to be eye level. This is now our mirror now. So eye level with our mirror means we can't go to the left or the right. We're not going to be eye level anymore. So our X is going to have to stay the same, but our Y can change. And we're how far away from this mirror here, this X axis? We are 1, 2 away. So that means we have to be 1, 2 away on this side. So this is going to be our A prime. Likewise for B, we are 1 away here, and we're going to be 1 away here. So this is going to be our B prime. And our C, we are 1, 2, 3 away. So we're going to be 1, 2, 3 away here. This is going to be our C prime. And if we were to connect all of these dots, we will get something like this. Once again, forgive me for not being perfect, but you can get the idea behind this. This is letting you know we have that mirror image. Once again, the shapes should be pretty identical, right? The only difference is, just like when you touch that mirror, we're going to reflect each other. This is a really good representation of how your mirror looks to you. This means we've properly reflected our graph over the x-axis. But before we say we finish, let's look at what we did before and see if we can find a rule for whenever we reflect over the x-axis. So our A, B, and C points are going to be A, B, C. A was 1, 2. B was 2, 1, and C was 3, 3. We just talked about that. So we have that. How about our A prime, B prime, and C prime here? A prime, B prime, C prime. What is A prime now? Well, A prime is going to be 1, negative 2. B prime is 2, negative 1. And you can kind of see what's happening here. C prime is going to be 3, negative 3. Do you see anything crazy happening here? Just like we discussed, our x's are going to be the same. However, our y's got negated. Same exact absolute value, but our y's have changed. We have different directions that we're moving, and we have a negative to show for it. That means that whenever we have a point P at xy, and we're reflecting over the x-axis, P prime is going to be x negative y. So instead of having the x be negative as we did for reflecting over the y-axis, the x is going to stay the same and our y is going to be negative here. So whenever we reflect over the x-axis or reflect over the y-axis, we have some quick shortcuts that we can do in order to figure out what our points are. However, I don't want you to get confused because you can reflect over a lot more than just those two axes. Let's look at one more really quick example in which we're not necessarily going to be on the x-axis or the y-axis. And we're going to try to reflect over it, and we'll see how we can't necessarily just use this as is. We're going to have to do a little bit of work. So for our last example, we're going to be reflecting over x equals negative 1. Now that's not going to be the y-axis. This is going to be this vertical line right here. I'm going to put a dotted line so we don't get confused. It's a nice dotted line at x equals negative 1. So this is what we're reflecting over. Not quite the y-axis, but slightly shifted. And this is going to be perfectly fine. However, we do have to do a little bit of work here. We can't just use our shortcuts as is. But what you do is going to be exactly the same. We're going to, instead of reflecting over y-axis, we're going to figure out how far we are from this x equals negative 1 for each point. We still have to remain eye level, so it doesn't matter if it's x equals negative 1 or y equals negative 1. It doesn't matter. You're going to do it the same exact way. But we have an x equals negative 1 here, so let's tackle that one. So A is going to be how far away from this x equals negative 1 here. We're going to be 1, 2 away. So that means we have to be 2 on the other side. So 1, 2. So A is going to be right here. So let's put our A prime here. How about B? B is going to be 1, 2, 3 away. So that's 1, 2, 3 away here. And we got to keep it eye level. So that's B prime. And it looks like we're going to potentially need some more space on this side. So let's add that. And we have a 5, 6, 7. Seems like it's going to be a little tight. So let's be a little proactive here. How about C? C is going to be 1, 2, 3, 4 away. So we're going to move 4 this way. 1, 2, 3, 4. So we're going to try to keep the same height and go here. And now we got to connect these points here. Let's put our C prime. And we're going to connect these to get our reflected graph. So this is how our graph looks when we reflect over x equals -1. It works just like we did for the y-axis, except we have to go out a little bit further. So let's compare our points and see if maybe there's a rule we can use. We already know that our A, B, and C are going to be the following points: 1, 2, 2, 1, and 3, 3. But how about this A prime, B prime, and C prime? What do we have for these points now? So once again, now we have the same exact what? X's or Y's. Did we move to the left or right, or did we move up and down? We moved to the left and right, so it means our up and down stays the same. So this is going to be 2, this is going to be 1, and this is going to be 3. Same exact Y's, but how did our X move? Well, we have new X's here. So for A prime, it's -1, 2, 3. So this is -3. For B prime, it's -1, 2, 3, 4, -4. And for C prime, it's -1, 2, 3, 4, 5, -5. So you see that for our A prime, B prime, and C prime, not only are your X values negative, but they're also off by 2, right? Whereas when we reflected over the y-axis, all we had to do was negate our X. This time we have to move it. So that means we can't use our shortcut. Remember, we had that shortcut. If we had P at XY, our P prime was just going to be -XY. That's not going to come into play here, and you can see very clearly why. So make sure whenever you're using these shortcuts, you have the right thing that you're reflecting over. In this case, you have to do a little bit more work, and you can't just rely on that shortcut. So I hope you have followed today's examples, and I hope you see that your geometric translations are going to be very different from your geometric reflections. But as long as you reflect over the x-axis or the y-axis, you have those wonderful shortcuts that you can make use of. If you had any questions about what you saw today, or even on homework, remember you can put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, smash the subscribe, hit the notification bell, and share this video with a friend. Well, that's all the time I have for today. I really hope it's helped with your homework, and I'm looking forward to see you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.